So this is going to be a couple examples related to the dot product. Okay. So this question says, find the acute angle between the curves at their point of intersection. Now, we have 2 points of intersection. We have a point of intersection here at 0, and we have a point of intersection here at x, which equals 1. Okay? So if we want to figure out the angle between 2 curves, what are we going to do? We're going to look at their tangent lines. Okay? And so if I look at the tangent line at this point and the tangent line at this point, and I do their dot product, remember that when we do the dot product, we have this formula. We went over this formula in class last time. So if we're trying to figure out the angle between 2 tangential vectors, we can say, well, you know, that angle is going to equal inverse cosine of A dot B divided by the magnitude of A times the magnitude of B. Okay. So to figure out what the angle is using this formula right here, what we need to do is we need to find a vector A and a vector B such that they represent the tangent lines of this guy. So how do we find a tangent line? Take its derivative. So the first thing we're going to do is we're going to take the derivative. All right? Now, and so, what is, let's start with the first one. Let's start with 0. Okay, so we just end up with a 0 vector. So in this case, when we talk about 0, we're talking about this, this spot right here. Now you might not think that that looks like that. You might say, well, that looks like there's actually an angle between them. There's actually not. If you zoom in incredibly close into this picture, what are you going to get? You're going to have this guy flattening off. Let's zoom in really close. This guy's going to be lower than that one, but he's also right there. Okay, so the angle actually equals 0. Okay, so by zooming in on that point, we can just pick up that that angle equals 0 at that point. So there's no difference between them. Okay? Their tangent lines are both having a slope of 0 at that point. But let's look at this other point up here. Okay. They're going to have different slopes at that point. Right? So, now y1 prime of 1 is going to equal 2, and y2 prime of 1 is going to equal 3. Okay? So you're imagining tangent lines. So so this is the slope of the tangent line at for the first curve, for y1. And this is the slope for the tangent line for the second curve, okay? So how can we describe this in terms of vectors rather than describing slope? Remember that slope is just rise over run. If we're talking about, just slope of a curve, okay? So since this is rise over run, we can say angle 1 is equivalent to rise over run 1 comma 2. Remember, the second one's the y value. Okay? And angle 2 1,3. And when I'm talking about angle, I'm talking about the slope of a vector. Okay, so whenever you're talking about the tangent line, you're talking about we go to the picture right here. Okay, so this guy would have a tangent line. Oh, this is going to be kind of hard to draw. Let me zoom back out. Okay, so I'm going to make this a bit bigger. Bigger one, let's put it right there. Left one. So I can make it bigger. That's not that big a deal. So that's really what I'm talking about right there. So you're talking about when you take the derivative, what does the derivative give you? The derivative gives you the slope of y, which equals x squared, which is going to have a slope of 2. And so we can draw that vector as 1, 2. Okay? Now this guy right here is going to have a slope of 3. That's the slope of the tangent line. We're not actually calculating the tangent line. We just want to know what the slope of the tangent line is at that point, which is related to the derivative. So we have two vectors that are going to be parallel to the tangent line. Okay? So what are we going to do? We're going to use the formula that we wrote down just a minute ago, and theta is going to equal cosine inverse, okay? This will be 1, 2 dotted with 1, 3. Now we have to divide by their magnitudes, which is going to be the square root of 1 squared plus 2 squared, and then multiply by the square root of 1 squared plus 3 squared. Okay? So those are our two vectors. We have the 1, 2 and 1, 3, according to the derivatives. Okay? And then all we have to do is we have to figure what this thing is. So that would equal cosine inverse. Okay, that would be 1 plus 6, or 1 times 1 plus 2 times 3. Now divided by the square root, 1 squared plus 2 squared is going to be 5. And then 1 squared plus 3 squared is 1 plus 9. That's going to be the square root of 10, which is going to equal, now cosine inverse of 7 over root 5 root 10. And what does that come out to be? Once again, I plugged it into Wolfram because nobody knows what cosine inverse of 7 divided by the square root of 5 square root of 10 is. Almost nobody. That ends up being 8.1 degrees. Okay. So that one's kind of complicated because we have to, we're going to have to plug that into a calculator or something to try to figure out what that one is. Let's do another one involving the dot product before we go into the cross product. Let's say this one appears in a slightly different way. I know most of you might want to pay attention to this one. This one also does. I'm trying to kind of follow y'all's homework, which I don't normally do in classes, but given the online nature of the class, I think it's somewhat more beneficial. Okay. Yeah, so let's do more of a geometric interpretation. So this is a square, meaning that all the sides have to have the same length. So if U is a unit vector, that means that W is also a unit vector, and they're perpendicular to each other. So U dot W is going to be the easier one to find. Okay? So I guess I'll stick with, I'll stick with degrees. So U dot W would equal the magnitude of U times the magnitude of W times cosine of theta. Okay? So the magnitude of U would be 1, magnitude of W is 1, and this would be cosine of 90 degrees. And cosine of 90 degrees is 0. You could have looked at that picture and said they're perpendicular. Remember, when it comes to the dot product, if you have two perpendicular vectors, well, the dot product is going to equal 0. If you have two parallel vectors, the cross product is going to equal 0. Okay? So this first one, they're perpendicular to each other. We would say, fine, whatever. It's going to equal 0. Okay, but then we have to consider U and V. Now, if I want to calculate U dot V, what do I need to know? Well, the first thing I need to know, well, I already know the magnitude of U because it's a unit vector. So the magnitude of U is going to be 1. But I got to figure out what the magnitude of V is. And since it's cutting that square in half, I know that the angle is going to be 45 degrees. Okay? But I still have to figure out what is the magnitude of V. How do I interpret that from this picture? Okay? Well, I know that if this is 45, this is 45, that is 90. Okay? So, what do I know from this? Based upon the Pythagorean theorem, okay, so if I'm looking at something like this is 1, and I'm trying to figure out what the magnitude of V is. This is a right angle, and that's also going to be the same, well, come on, it's wrong. That's the magnitude of V. So a squared plus b squared equals c squared. So the magnitude of V squared plus the magnitude of V squared is going to equal 1 squared. Okay? So if I add these two guys together, that's going to be the magnitude of V squared, well, I'll do it in 2 steps, equals 1. So the magnitude of V, well, squared equals 1/2. So the magnitude of V is going to be 1 divided by the square root of 2. Okay, so I've got the magnitude of U, the magnitude of V, and I know the angle. So, U dot V, which equals the magnitude of U times the magnitude of V times cosine of theta, close that, is going to equal 1, now multiplied by 1 divided by the square root of 2, and cosine, hold on one second until I get done with this. 1 divided by the square root of 2 multiplied by the square root of 2 divided by 2 equals 1 divided by 2.